Hello again. Thanks for joining us. This is Space Nuts Q&A. My name is Andrew Dunkley, and good to have your company again. Questions today coming from Michael, Rennie, Joseph, and Ralph. Michael wants to look at dark matter. We've got a Big Bang question. We'll talk about the early universe, and that three-body problem has come up again. That's all to be discussed on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And he's back again for more. Professor Fred Watson, astronomer at large. Hello, Fred.
Yeah, just send those questions and we'll get onto them.
Yep. Just can't get enough.
Can't get enough. No, that's right.
We might as well start. This first question comes from Michael in Illinois. Michael in Illinois. Gentlemen, what a fantastic podcast. Which one are you talking about, Michael? Absolutely fabulous for the space nuts like me who love space but just have just enough knowledge to be dangerous. Two questions. Can dark matter be the fabric of space-time? I don't think so, because you've addressed this topic, but I can't for the life of me recall what you said. What technological advances would you most like to... Oh, this is his second question. What technological advances would you most like to see happen within the foreseeable future? Here's the kicker. It has to have appeared in science fiction stories. Mine is Space Elevator, which Arthur C. Clarke described in The Fountains of Paradise, published in 1979. That comes from Michael in Illinois. We'll get to that in a minute. Okay. Dark matter, the fabric of space-time? Yes, no?
Probably not. It's no. And that's because we can map dark matter. We can map where it is by looking at the fact that it warps space itself. It warps space rather than being the fabric of space. And that warping can be revealed by looking at what it does to galaxies beyond the ones that are warping. There's somebody warping in the background. Good old Geordie. Can't resist it. Oh, shut up, Geordie.
I love it.
We've got our very own space warp here. So dark matter warps space, so we can map where it is, and we know that galaxies are immersed in these huge blobs of dark matter. So dark matter is definitely something within space rather than the fabric of space itself. It's still a puzzle. It's still unknown actually what it is. And we believe it's some species of subatomic particle that is invisible in every way except by its gravity. And we are still looking for it. We're looking for the particles. We know that for every kilogram of normal matter in the room that you're in and the room that I'm in, there's 5 kilograms of dark matter as well. What do we do about that? We don't know what it is.
Yeah. Wow. It's hard to get your head around, though. I can understand people trying to come up with answers for this because it's not an easy one to wrap the mind around, and some of the best experts in the world still can't agree on what this is.
Exactly. And there's some widely disparate views of what it might be. And we have many times raised the issue of MOND, the theory of modified Newtonian dynamics, which suggests that our understanding of gravity is wrong, and it's not that this dark matter exists. But I think that's still regarded as speculative by mainstream science. I think most astronomers are convinced that there are these subatomic particles that we are yet to find.
All right. So, Michael, go on.
No, I was just going to say, it's one of the reasons for, the Large Hadron Collider at CERN in the on the Swiss-French border, the European Nuclear Research Centre. That was the collider where the Higgs boson was found back in 2012. They've got plans for something called the FCC, the Future Circular Collider, which will make the Large Hadron Collider look very small. One of the reasons for doing that is to look at subatomic particles with higher energies, with the hope that they will reveal whatever the particles are that make up dark matter. So there are plans to try and sort it out, but it's still very much an open question.
It sure is. Okay, Michael, that was part one of your question. Part two, what technological advances would you most like to see happen within the foreseeable future? Here's the kicker. It has to have happened in science fiction stories. He likes the space elevator that was written about by Arthur C. Clarke. We've talked about space elevators before, Fred. What is it for you? I had a long think about this, and I'm still pondering. Have you come up with anything?
The kind of thing. So my go-to place in science fiction, of course, is Dan Dare back in the 1950s. Dan Dare, the pilot of the future, and so much of what Frank Hampson, the author of Dan Dare, and he's a fabulous artist and illustrator, but also a man with a good command of science. The sorts of things that he was talking about were little personalized flying machines. Well, we're seeing those already. You can now buy a Jetson 1, which is basically a flying machine that you can sit in, do 20 minutes of flight at up to 100 kilometers an hour. The waiting list is quite long. I think you won't get if you order one now, you won't get it until 2026. And the other one, that Dan Dare used all the time was he had a watch that let you talk to people with. Well, I've got one of those now. It's incredible. So a lot of what was forecast back there in the 1950s is basically happening to us now. I guess the technological advance for me that would really dramatically change our entire existence would be for the manipulation of gravity. I mean, we've talked about that before. How can you tweak gravity so it does things for you that you want it to do? At the moment, we're just stuck with it. Any massive body distorts the space around it, and we feel that as gravity. Could you warp space to let you move more readily through the universe, the good old wormhole technique and things of that sort. I know that's very much on the, well beyond the horizon of anything that we're thinking about at the moment. But just a quick comment on Michael's favourite, the space elevator probably won't happen just because of the debris that we're surrounded by in Earth orbit. And it was a guy called Buzz Aldrin who told me that at dinner once when I was lucky enough to have dinner with him. He said, space elevator is a great idea, but it won't happen. And that's because every bit of space junk crosses the equator twice in its orbit. If you've got to have the space elevator on the equator, else it doesn't work. So you're always going to get collisions. And so he wrote it off in no uncertain terms. Bit disappointing, really.
It is rather, but not surprising. We humans have a tendency to make a mess. And
we do. So what was your technological advance, Andrew? What did you
you kind of touched on it with when you mentioned high-speed travel. I think, let's steal one from Star Trek, I think if you could achieve warp speed, that would be, for me, a wonderful innovation in terms of even just travelling within our own solar system. And I know they're working on different kinds of engines. NASA's looking at different types of engines to try and increase travel speed. And we talked about it recently, being able to get to Mars in 2 months instead of 6 to 9 months. I would dearly love to see that kind of technology perfected so that we could get around our own neighbourhood very fast. And that was portrayed well in a TV series which I watched for a second time recently called The Expanse, where they had developed a way to travel within the solar system, and you could do a trip from Mars to Pluto or something in a few weeks versus many years. That to me would be a great innovation. It would make exploration of the solar system so much easier, and people would be able to move around with expediency, which we cannot do at the moment. So I think that would be, whether or not it's warp speed or some kind of pulse engine technology that makes us move faster. It would have to be highly efficient as well. But I know they're working on it. So that to me would be the next big thing. But, the other one I'd like to see is space tourism happen. I think it's already started with little sort of trips up and back. But I think having a space motel, for example, in orbit, I'd love to see that happen. I think that would be the next big thing in tourism. And it would be a lot of fun.
There's precursors up there already. Is it Bigelow, the company? It's a very big company of hotel chains within America. Back in the early 2000s, they developed an inflatable module. In fact, they launched two, I think. I think they're still in orbit. There was one that was also attached to the International Space Station, and it was for exactly that.
That's right.
Think about space hotels, the Bigelow inflatable space modules.
That just scares me, though. It just
Do you want to be in a balloon in space?
No. Yeah, I'm not sure, especially with all that junk flying around. I'm not real sure.
They actually, they did say that it was more resilient to impacts by small pieces of space debris because, unlike a piece of metal, get a hole in it and the hole's there. Some of these fabrics that they used in the test modules actually heal themselves, so that the hole blocks up very quickly.
Oh, that's interesting. Actually, one thing we learned when we were in China, we went and visited a silk factory. And I used to have silkworms as a kid, but they were telling us that the strength and durability of silk is so strong they actually use it in bulletproof vests.
Yeah,
I didn't know that.
Remarkable,
incredible stuff. Okay, thank you, Michael. Let's go to a question from Rennie Traub. How energetic was the Big Bang in comparison to the most powerful supernovas or gamma ray bursts ever discovered? Science is exciting, Rennie says.
It is, and that's why we're still doing it. Plus the fact that it's helpful occasionally. Look, I don't know the strict answer to this in terms of a million times or anything like that, but the Big Bang was the Big Bang. So it was the energy that was released in that means that even the most powerful supernova really pales into insignificance. Although supernovae are often described as the biggest bang since the Big Bang, but they're vastly less energetic than what was involved in the creation of the universe, as you'd kind of expect it to be. A supernova leaves a debris cloud around it of enriched material. The chemical reactions that take place in the heat of the supernova create some elements that are quite rare. But that's just spread around its locality, whereas the Big Bang created everything. So yes, the ratio of one to the other is a very big number indeed. I don't know what it is. I'll try and check it up, but I'm not sure that I'll find the answer.
Yeah, I imagine the difference would be just staggering. Like we'd be talking billions upon trillions of megatons in variation between a supernova and the Big Bang. I imagine the Big Bang was, we're still seeing the after effects of it. It's still going, technically.
That's right. 30.8 million years later.
Yeah. A short answer to that question, Rennie, but it's chalk and cheese, basically, by the sound of it. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
3, 2, 1.
Space Nuts.
All right, let's keep rolling with the questions. Hey, Space Nuts, given the early universe was believed to be a dense, hot plasma, could it be that at this time large, gargantuan level primordial black holes formed, which could explain the recent James Webb images of very distant, enormous and distant black holes that could have formed at the very start of the universe before the black holes that formed from more recent star collapses? And also further to this, could it be a source of naked singularities as well that may have formed from failed black holes in this early time? Could these naked singularities be so numerous and widespread that they account for the missing mass we infer but cannot see? Could this be all the dark matter? Love the show. Keep up the great work and hope to see you around Dubbo in 2028 for the eclipse. Joseph from Melbourne. Yeah, we've got a spare bed, Joseph, so that's a distinct possibility. I'll take beds.
Take beds, yeah.
Yeah, interesting thought.
They are. So let's do the second bit first, about the idea of naked singularities or black holes, effectively. Representing the missing mass. By the missing mass, I think we mean the dark matter. Missing mass is slightly different. That's normal matter that should be there that seemed to be missing, but we think we found it now in the electrons between the galaxies. But dark matter, yes, as we've been talking about, it is just a something that is invisible, only revealed by its gravity. And the reason why we don't think it's lots and lots of primordial black holes is because of some experiments that were done in the 1990s. We used to think that there might be things called MACHOs, MACHO, which was massive compact halo objects. And that meant exactly what we're talking about, black holes that were lurking around the outer regions of our galaxy. But in an experiment, which funnily enough was also called MACHO, done with one of the telescopes actually at the Mount Stromlo Observatory in Canberra, as well as other places throughout the world, many experiments were done to try and identify whether MACHOs were the dark matter. They failed to see enough what's called gravitational lensing. If we had these little black holes everywhere that were enough of them to make up the dark matter, we'd see lots of instances of these passing in front of a distant star and acting as a magnifying glass because of the gravitational distortion around it. So you'd see a gravitationally lensed image of the star. It would suddenly get brighter and then fade away with a particularly characteristic light curve, the way the light behaves over time. And they weren't seen in enough numbers. They did see some, so they knew that the technique was working, but they didn't find anywhere near enough to make MACHOs the dark matter. And that's why it became WIMPs, which is what we now think they are, weakly interacting massive particles. And so the answer is no, probably not. And then going back to Joseph's first question, I think he's kind of on the money with this and really looking at research that's only been in publication for 2 or 3 months. Which came first, galaxies or black holes, or the supermassive black holes. And exactly as he says, James Webb Telescope shows images of galaxies which probably have very large supermassive black holes at their center. And the conventional wisdom has always been that the supermassive black holes probably formed by lots and lots of stars reaching the ends of their lives, exploding into supernovae, creating a black hole, which then gets absorbed into another one, and you've got a supermassive black hole at the end of it. We are now seeing doubt being cast on that by a paper which was led by a well-known cosmologist called Joe Silk, another Joseph. He and his colleagues have postulated that maybe the black holes were actually formed in the Big Bang, and these black holes became the nuclei of galaxies. I'm hoping actually to find out a bit more about this theory later in the year, Andrew, because one of Joseph Silk's collaborators on that paper is an old friend and colleague of mine, Professor Rosemary Wise. She's at Johns Hopkins University in the United States, and she's coming to Australia to help us celebrate the 50th birthday of the Anglo-Australian telescope. So I'm going to try and bend her ear about that and find out what it's all about.
Yeah, wow, that'd be great. Yeah. All right, so the answers to Joseph's questions were no, yes.
Well, perhaps a no, I think, are the answers, to take them in the order that Joseph set them out.
Fair enough. Thank you, Joseph. Pretty deep question, but we like to try and tackle them. We don't always have the answer, but that's because probably nobody does have the answer a lot of the time. One final thought, Fred. This comes from Ralph, who's messaged me before about the story Three-Body Problem, which is originally a book series by a Chinese author, but it's now been turned into a TV series. Andrew, thanks for your advice on the Three-Body Problem book. What I suggested he do was get his device to read it to him rather than struggling through it himself, because I taught mine how to read to me, so I don't have to, because it is a really tough read in the original manuscript. Anyway, Ralph says, I gave up on the book, but I want to know what you're up to on the mountain. So I have I want to know what they're up to on the mountain. This is where they made their first communication with the aliens. So I have the audio book on hold from the Indianapolis Public Library. I hope to get it soon, Ralph. I guess with the series coming out, it's become popular and people are grabbing audio books because the read is really tough. I'm still pushing on with it, Ralph. I haven't finished it yet. I find myself sort of reading a few chapters and then having to have a rest and a lie down with a headache tablet. But it is a tough read. But I'm persisting. I want to finish it, so I'll keep going on it. But whatever you can do to get through it is my advice. And Ralph's found a way. So let me know how you go with it, Ralph. I have heard on the grapevine, Ralph, that they've decided to continue with the series. I think it's on Netflix. They originally were going to only make two seasons. In fact, they were just going to run the second season as an add-on to the first season and just do it as one series. But now the latest is they've decided to make 3 series. So it will follow the 3 books in the written series as a TV series, and they're going to follow it as closely as possible. And from what I've read so far, they're sticking to the actual manuscript. So yeah, that's what I've heard about Three-Body Problem. Three-Body Problem, basically, Fred, I think I explained before, is these aliens live in or come from a planet that is unfortunately in orbit around 3 stars, and when you get 3 big bodies with all the gravitational influence that they possess fighting over a tiny little planet, it's not a nice place to live. And so they've decided to move out. And we made ourselves known, which Stephen Hawking always said could be a problem. Well, that's basically the situation in this book. But it is a really great series, and I'm enjoying the book, as difficult as it is to read. It is super technical, and it's so technical that he's got reference numbers all through the manuscript of the book. So if you're not sure what he's talking about, you can click on the number and it will take you to the reference page so you can understand what he's trying to tell you. It's a really tough read, for someone as meagre as me in terms of technicalities. But
I did.
Anyway, there's the update.
I did recently, Andrew, come across a website. It might have been on The Conversation, which was about the science of the Three-Body Problem book. And I thought I bookmarked it. I've just been looking through my bookmarks and I can't find it. But if I find it, I meant to send it to you.
Send that to me.
Yeah, I meant to send you the link. And that was a couple of months ago, actually. And I kept forgetting to send it to you. But I'll find it and drop it along to you. Yeah.
All right. Love it. Thanks, Ralph, and thanks to everyone who contributed. Don't forget, if you've got a question for us, send it in through our website, spacenutspodcast.com. You can just click on the links, the AMA tab at the top for text and audio questions, or the Send Us Your Questions button on the right-hand side. If you've got a device with a microphone, you are all set. Don't forget to tell us who you are and where you're from. Thanks, Fred, as always.
It's a pleasure, Andrew. Always good to talk, and especially when you've been away somewhere.
Yeah, just that little trip to China. Not much stargazing to do in China. It's
no, I can imagine.
Not many clear days. Although I had to laugh. Our guide on the first few days said, we've been cleaning up our act. We've been moving industry away so that the city of Beijing can enjoy blue skies like today. And I looked up and went, oh, yeah, there's a patch. There's a tiny little patch of, yeah, but look, they're working on it. Thanks, Fred. We'll catch you soon. And, of course, we also like to thank our stand-in producer, Geordie, this week in the absence of Hugh. And from me, Andrew Dunkley, thanks for your company. Catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.